sometimes you're going to see in a word problem some really disturbing information. You're going to see something like this. In 36 degrees, 40 minutes, 33 degrees, 22 minutes, east, south, east, north. Oh man, is that ever confusing looking? But I'm going to show you that this is not bad. You can get this easily. And it's just understanding what a bearing is. We're going to take a compass bearing and change it to a true bearing. True bearing is super easy. You start out at 0. So the 0 degrees is here. True bearing starts north and goes clockwise 90, 270, 180, 270, and then 360 or 0. So you're going to go this way and go around until you get back. Compass bearings are a little bit more straightforward. If you see north 70 degrees west, all you do is you start at this direction. So what I'm going to do is I'm going to take this guy here, start it north, and then it's going to sweep 70 degrees in this direction. So west is this way, and we're going to sweep, if this is 90, 70 would probably be like that, from here up to here. And so that's north, 70 degrees, sweeping west. So you start with that direction, and you sweep, I call it sweep, in that direction. Okay? Well, true bearings are going to be 90, 180, 270, plus how much will this be? If this is 70, this angle should be around what? 20? Okay, so what's 270 plus 20? Yep, so this would be 290 degrees true bearing T. Write that in the blank. Let's try one more. I'm going to go north, sweep 20 degrees east. So here's east. 20 degrees is about there. So now it's going to be here. And so for the true bearing, this is kind of ridiculously easy. You're going to start north, 0, go 20. This is just going to be 20 degrees true bearing. You try these two and these two. See if you can fill in those blanks. Good luck. Let's see how you did. Let's crank these out. So we're going to start with west, 40. So we start west. 45 degrees south is going to split this in the middle. So got a 45 degree here. So it'll be 180 plus 45, which will just be what? That 225 true bearing degrees true bearing. Try the other one, east. So we start off east. Sweep 60 degrees north. Oh, that's going to be easy. We'll just leave us with 30 degrees here. Or we'll have 60 degrees here. So you could have, some of you may have done this two different ways. Maybe you said start north, sweep east. And if you do that, you sweep 30 degrees east. Or you started east and you swept north. What would that angle be? 60. How many did started north? How many started east? Okay, wow, really? Most of you did that. And you see why that's 60? Good. And then for true bearing, you're going to start here, you're going to just go 30 degrees. So it's just going to be 30. Oh, I'm thinking ahead here, excuse me. I'm thinking ahead to this one. I only had one. 85 degrees true north. So here's 90, so backing off 5. So this is going to be 85. 85, and this will be 5. All right, so we started here. We were at north swept 85 true bearing, and this was 5, and this was 85. So this is going to be north sweeping east, so it's going to be 85. How many did that? North sweeping east, 85 degrees. How many went east, 5 degrees, sweeping north? How many did that? Yeah. Can they do anything different? Start south? You could. But those are the two common ones. So you'll have either one of those two answers, and then for the last one, we'll do 210. So here's 180. 210 is going to be here with that 30-degree angle. So we'll have two possibilities. We'll either start west, and we'll sweep south 60, or we'll start south, and we'll sweep how far? 30, yeah. And how many did west first? How many did south first? Both are correct. And you're good. Any questions about bearings? True bearing starts north and sweeps clockwise. Good. Just real quick here, angle of elevation. Put your hand right flat on the desk with your elbow on the desk. And then would you angle your palm off the table? That's the angle of elevation. From the table, up is your angle of elevation. That would be like from a person sitting on a bench moving up, theta. Okay, now move your, go angle of elevation, everybody. Now move your elbow parallel. Now go down to the table. That's the angle of depression, going from level down. So level down is the angle of depression. Level up is the angle of elevation. And if you look at your geometry, what can you tell me about the angle of depression and the angle of elevation? What can you tell me about those two? You know your geometry. If these two are parallel, what can you say about these two? They're equal, yeah. Angle of elevation. One more time, put your hand flat on the desk, elbow down, move your palm up. That's angle of elevation. Now put your elbow up, parallel. Now put your palm down to the table. What is that? Depression. You got it. All right. So when you do a word problem from me, I'm really big on sketches. So if you're drawing any kind of a triangular situation, label where the perpendicular is. Maybe use a different color to say maybe this is the height we're looking for. Maybe this is 5 meters. Something like that. And then use a different color for your angle. Let's say this angle is 27 degrees. This angle is a 90 degree. Just put in as many labels in your sketch as you can. Maybe this is a building. So you've got, a building here with people in it. Okay? Or maybe there's a river going by. Just label it, but with your triangle, that's going to be what you're going to be solving off of. Don't forget to label it as well as you can. Include your measurements, box your answers, solve. That's great. So if we took a problem like number 4, find the angle of elevation from a bench to the top of an 80-meter building, if the bench is 105, we can just start thinking, okay, here's the bench. It's 105. The height, here's my height. Height is going to be, what did they say, 80 meters? There's my height. The bench distance is 105 meters, and we want the angle from level up, angle of elevation. So I draw this triangle here. This is 80, this is 105, and this is theta. What relationship is there between this one, and theta? Opposite, adjacent, and theta. It's either sine, cosine, or tangent. How many think it's sine? Cosine. Tangent. The tangents have it. It's the tangent of theta will be equal to 80 over 105. Now I need your help. We're going to undo tangent to figure out how many degrees, minutes, and seconds this is going to be. So take your calculators out. So take your calculator. Make sure you're in the degree mode because that's what it's going to recognize. All right, and so here goes. Clear this. Going to go undo tangent of 80 divided by 105. Now, when I do that, I'm going to get a weird looking decimal. And did I show you how to subtract 37 and multiply by 60? What was our shortcut for doing that? DMS, second apps, there you go, angle, 4, DMS, degrees, minutes, and seconds, and then there's your answer. There you go. It is theta. Theta is going to be, theta is going to be 37 degrees, 18 minutes, 14 seconds. And this one's going to require a little bit more thinking than that last one. It says, from to position on a roadway, we notice some bearings to a tree. So I'm going to start at this point, going to have the tree right here going like this. Now, they're saying that these are 400 meters apart, these 2 points, here and here, and it says one of the bearings is north, 36 degrees, 40 minutes, sweeping east. So that's going to be this one right here, 36 degrees, 40 minutes, that's this angle. The other one has kind of a little line going out like this, parallel, and with this one, it's east sweeping south, 33 degrees, 22 minutes. And we want to find the shortest distance from the tree to the road. It looks kind of like that. I'm going to give you one hint, and that is going to be, I'm going to call this distance here to the road x, and this distance here, 400 minus x. Get somewhere with this one? How many got somewhere with this one? What did you do?
Well, I didn't solve it. I haven't got to it yet, but I figured out that you could find the angle of the corners.
Oh, these 2 corners?
Yeah.
Love it. So what will this angle be?
I haven't solved it yet.
Okay, but if this is 33, this will be 33, so this will be, I want to say, 56. Did you say 68? Yeah. So I'm going to make a triangle here, and this is 56 degrees, 68 minutes. Do you agree with that? Is that what you were saying? Because it's 90 minus that. A little tricky. And you could, you know what I would do if I were you? I would just leave that. I would just leave this 33 degrees, 22 minutes. I'd just leave it. You don't need to subtract them if you don't want to. And then this is x, and this is the distance that we're looking for. So the tangent of 33 degrees, 22 minutes, I'm going to need your help with your calculators in a minute, will be opposite x over d. Then this one down here is 36 degrees, 40 minutes, and this distance is d. This is 400 minus x. So now when I take the tangent of this guy, tangent of 36 degrees, 40 minutes, it's going to be opposite d over 400 minus x. How are you doing? Is that part all right? Now, unfortunately, the rest of this is huge amounts of algebra, and not pretty algebra either. But I would recommend that you get a 4-digit or 4-decimal number here. 4-decimal number here. Did anybody get the tangent of 33 degrees, 22 minutes? Anybody get that as a decimal? Point what? We'll need 4 decimals equal to x over d. And then do the same thing here. 4 decimals equal to d over 400 minus x. Anybody get this one? I think this is like 0.7445. Is that right? Anybody second that? What's this guy? 0.6585, and is this right? 0.7445? I think I remember that from last hour. All right, so now you're going to take this one, and you're going to cross multiply 0.6585 times d will be equal to x. And then I'm going to cross multiply these 0.7445 times 400 minus x is equal to d. Now this one's a little bit of nonsense here, but you're going to go divide by 0.7445, and you're going to get 400 minus x equal d, 0.7445. I'm going to switch these two around so you get 400 minus d over 0.7445 equal to x. So what that'll mean is if you have x equal to 400 minus d over 0.7445, and if x is equal to x, could you solve for d? 400 minus d over 0.7445. Could you solve for d? Could you? Yeah, and I'm not going to do it, but you could. You got one variable there and you're good to go. So let me just walk you through real quick. The main thing you want to do is get your triangles and use SOHCAHTOA to relate variables that you don't know. Now we have 2 here we didn't know. That made it a little tricky. And then you're just going to solve for one variable you don't want, which is x, and then be able to solve for the variable you do want, which in this case is d. Put those together on one side, solve, and you'll get d. Pretty gratifying when you get that answer, which is the distance between those two. For Monday, you did this one here, number 2. You're going to do number 8 as best you can, and I'm just going to warn you, 8 is a little trickier than number 9. 9 is a lot easier between the two of them. So do 8 and 9, and that's plenty.